followed along with Alex. Rust by Example Session 3. Let's get started. Okay, so last time when we were working through this, tutorial, we stopped with the primitives. And so now we're going to move on to the custom types section. And so this is where we can define our own types, using the primitives that we previously covered. And so Rust has a few keywords to define custom types, and there's struct and enum. And let me share the link in the chat real quick. Cool. And this will also go in the YouTube video for those watching asynchronously. Cool. Also, constants can be created using the const and static keywords. So it's kind of some similarities to other languages, like maybe JavaScript, TypeScript stuff. But yeah, let's get into structures. So now I'll start doing some code. Before we get too deep, let me create a file called, we'll create a new directory first. Make dir. Oh, that's like super squished. Let me clear this. Okay, make dir. We'll call it 03 custom types. Okay, and then let's also, I'll change into that directory. And then let's create a file called structures.rs for our code. Cool. Now we'll open that up in VS Code and we can get started. Thanks for bearing with me. Cool. So now there's 3 types of structures or structs that can be created using the struct keyword. I'm just not showing the Rust by Example documentation on my screen, but that's kind of where I'm reading it from. And so the 3 types of structures are tuple structs, which are just basically tuples, classic C-style structs, kind of influenced by the C programming language, and then unit structs, which are they're fieldless and useful for generics. Cool. So let's get started with some coding. So Rust is very verbose in its errors, and so by default it'll kind of yell at you if you have code that's not being used. So let's kind of tell Rust to chill out. Like, it's okay. We want some dead code for now. We're still learning. We want to leave some. If we're like writing production optimized code, yeah, it's great to like have this kind of checker, but for what we're doing, it gets a little annoying. Cool. So that'll hide warnings for unused code. Let me save that. Awesome. Now let's create a struct called person, and we're also gonna add a derived debug attribute just so that we can easily print out information as we're writing our code. Cool. So derive, just because by default Rust has no clue what to do with our random custom data type, and so I could be slightly wrong, but I believe the derived debug attribute lets us kind of easily just print out some stuff for ourselves as we're developing what is likely not optimal for production code or for end users to actually touch. Okay, so we have our person struct, and let's create a unit struct now. So it's really just simple. Semicolons are weird for me. That ring finger. I cheated with type to learn in elementary school. That's what I get. Shouldn't have cheated. Okay. And so now we have a tuple struct. So we're really just going through, it's actually struct. And we're just kind of demoing the different types of structs that were described in the REST by example documentation. All right. Let's make a point struct. And you can also see we're declaring data types for each of the struct fields or attributes. So X and Y are both float 32s. In the previous pair struct, you can see that the elements are I32 and F32, so integer 32, float 32. All right. Let's save again. And then you can also nest structs, which is kind of cool. And so as you build more complicated programs, you might want to reuse kind of logical components, just like maybe a front end. You'd have components that you're reusing, but the same could be true for the back end program logic. And so being able to nest structs is super handy. So an example of a nested struct, we could have a rectangle struct, and then to define the rectangle, we're using a top left and bottom right coordinate point, and that's of type point, which we defined previously. Cool. All right, so we defined some structs. And now let's actually write a function to do some stuff instead of just declaring data types. So let's call it main. And let's create some structs with the field in int shorthand. So even more examples of struct creation. So we're creating a struct from the spelling is challenging. Cool. And then so our person is going to have a name Peter and an age equals 27. We don't have to declare the data type for 27 just because Rust is intelligent enough to figure that out. But so now let's create this variable person, Peter, and we'll pass name and age. Cool. Nice. Save this real fast. Now we can print out our results, and because we didn't implement the fancy like printing logic for this struct, we're just going to use the debug syntax with the colon and the question mark inside the curly brackets, and that lets us just kind of lazily get the output that we want to see without implementing the fancier print stuff for person. Cool. I hope you like my very technical jargon print stuff. Okay. So now, actually, let's just see what the output of this program is without implementing anything else. So to run this, I believe we just do rust c and then structure dot rs. And so you can see I have some errors. Let's see where I messed it up. I think I'm missing an exclamation point or something, but we'll see. So let Peter, I'm missing a semicolon. Okay. It's just yelling at me for that. Now, I think besides that, we should be good to go. So let's Run it again. And nothing prints out. Interesting. Interesting. Can we do Peter.name? Let's see that. Interesting. That is bizarre. Maybe I'm doing something incorrect. Let's check my history if there's anything from when I left. It's gonna be a while. I have not been doing Rust recently, as you can tell. Let's check the docs to see what I'm perhaps doing wrong. Okay. That's what I was forgetting. I gotta actually call the program. So the Rust C is just the compiler, and now I actually have to run the structure program, the executable or the binary, and now you can see Peter. Okay, so that's where I was messing up. It's been a minute. It's okay to be rusty. It's Rust. See what I did there? Okay. Let's go. Okay, everything is working as expected. Let us do some more coding. So enough with Peter. Let's move on with points now. So let's instantiate a point. No offense to Peter. It's just, let's move on to other things. So we're creating a lowercase point variable of type point, and then let's pass the values. So x is gonna equal 10.3, and then y is gonna be 0.4. And then let's just print out the fields of the point. I kind of foreshadowed this previously while I was debugging my forgetfulness in Rust, but you can access the fields of a struct by using dot notation, and we're gonna do that shortly. So we're just gonna print out the point coordinates and do a little bit of kind of string interpolation, and then we're just gonna pass the values we'd like populated inside the curly brackets after comma. Cool, so we're gonna pass the point x and point y fields into our print string. So let's see what that looks like now. So let's recompile our program, and then I'm kind of lazy, so I'm gonna make it a single liner. So we should be good. Hopefully this works. I think it will. Yay. Okay, cool. So you can see we have a person, Peter, age 27, and then we also have a point struct with coordinates 10.3, 0.4 as we declared in our code. Cool, things are working as expected. That's what I like to see. Next, we can make a new point by using the struct update syntax, and then we can use the fields of our other struct. And so we're just kind of building some intuition about how to work with structs in Rust. So it's kind of like doing the same thing 10 different ways, but yeah, it's not terrible practice, but it's likely not the most exciting. Just want to be totally transparent. I'm predominantly like a Python developer for my day job, and so it's interesting, all these curly brackets, and it's a little different, and like question marks, but it's not too wild. It's definitely a little different. So you can see we're for the bottom right struct, we're passing a value for the X field, but then for the Y field, we're just gonna kind of, I guess, inherit from the existing point struct and just take the Y value. So let's see how Rust handles that kind of value transfer functionality. So let's do another print statement just to see what that looks like. So we're just gonna output our second point, do some similar kind of curly bracket, string interpolation. This is reminiscent of Python and other programming languages, just missing maybe an F before the string. Cool. So we're using our bottom right struct, passing the X value, and then again, we're gonna do the bottom right and then pass Y. And so let's compare the output of our bottom right struct and our point struct. Cool. Okay, that looks good to go. Now we can save or rerun this. Something's broken. Where did I mess up? Okay. There's nothing wrong with messing up. It's just part of the process. Okay. So it's let bottom right unexpected token. I'm missing. I keep forgetting the semicolons. You can see I'm not like a TypeScript or JavaScript developer full time. I dabble as necessary, but you don't need as many semicolons in Python or like CI/CD stuff. So I forget, and it's okay. The nice thing about Rust, it reminds you, like, add it here, as you can see in the error output. And so if you get over the kind of the red text of fear and doom that something is broken, it's pretty chill. Rust is super helpful about letting you know where you need to just add something, and then your program will work. Cool. So let's rerun. And you can see now that we successfully created a second point struct that, I guess the value of our first point struct Y field was transferred over to the second point struct, which is kind of cool. So if you have maybe a generic value that you want to apply to all structs for a certain field, you can easily do that while adjusting a different field as necessary. So that's just kind of like a convenience functionality that I could see being useful down the line. All right. Next, let's move on to some destructuring. So I think I've predominantly seen this in kind of JavaScript, TypeScript contexts, like object destructuring, but it's cool that we can do some of that here in Rust. So let's add some new lines here. So let's create another point. This is inside our logic though. So the previous point was globally declared, or no, it's not. It's up here. So apologies, it was not. And so this is now uppercase point. Okay. Don't get tripped up on cases, y'all. It can get tricky when you're using the same name for things. So this is where it can be helpful to like name your variables according to their functionality. I mean, this is a toy example, so we're using point for like 4 things, but you can see how it gets a little confusing, especially in a non-trivial example. But we just, instead of first declaring the variable name and then kind of instantiating a struct, we are first passing the struct with values and then letting that equal a point variable. And so this could be like any name, but I'll just call it point so that any following kind of exercises don't break. Awesome. So now I don't believe we have a left edge and a top edge declared yet. Oh, we do. Okay. Okay. So next, let's create a rectangle. As you can see, this is like thrilling, but it's part of the learning process. Even just helping me build some muscle memory for Rust programming to remind myself I need to use plenty of curly brackets, colons, and semicolons. So it's a mixed bag, but yeah, I feel like we're still not doing anything wildly mind-bending. We're still, for the most part, just like printing things and accessing like nested variable values. But that's a lot of programming, to be honest. It's like data query stuff and ETL, extract, transform, load. So general purpose kind of programming, not like building a user interface. But cool. So this is now finished. A struct instantiation is an expression too, according to the docs. So you can see we have this rectangle variable of type rectangle, and then for the top left variable, we pass a struct instantiation instead of another variable, and then for the bottom right, we're just passing a bottom right variable value. So there's lots of ways to create structs and nested structs. I feel like that's the take-home message from this lesson. So now we're instantiating a unit struct. We can instantiate a tuple struct. And these are all types that we declared above. Nothing super fancy. And now we're going to print a couple lines just to make sure everything is working as expected. So here we're going to print out the pair and use some of the kind of lazy debugging format to print out without having to worry about type and implementing the pretty printing stuff. And so it's convenient, but it definitely tripped me up in the beginning, forgetting to add the colon question mark and then just running into error upon error and things not printing. So if you're not actually implementing the pretty formatted print, then just make sure to pass the colon question mark for when you're just developing and troubleshooting logic. Cool. Pair 0, pair 1. And you see I almost got an error message, but I caught it. The semicolons, man, so many. It's my right ring finger is not like used to that action. It is what it is. So we're doing some more destructuring practice, just really kind of trying to hammer that point home that this is something that you can do in Rust, and it may become useful down the line. And then our final print statement for this program is, you can see we're using our trusty colon question mark twice. And we're going to pass integer and decimal just to see what comes out. Sweet. So let's save this, and then we can run our program and make sure everything is working as expected. I hope it is, but you never know. It's part of the excitement. Things break sometimes, or oftentimes. As you can see, they broke. So it looks like it doesn't like something. Demisel. So I spelled something wrong. Where did I spell it wrong first? Where's Demisel? Yeah, spelling is hard, man. This what happens when you don't copy paste. There we go. Okay, yeah, Demisel. Decimal. Nothing too tricky. Rust has our back. It let us know that there's something similarly named. That's super convenient. I don't think Python does that. I don't think TypeScript does that. That's like super nice. just from like a quick debugging perspective, I really appreciate that. It's like, oh, this, you probably meant this, or like, yes, thank you, Rust. Okay, and we still got some errors. Let's see where we're erroring out now. Let me expand my terminal a little bit, help us out. A lot of errors this time. Okay. Expected semicolon, found keyword let. Okay, so I definitely forgot a semicolon again. What line is this on? Line 35. Okay, yeah, those tricky semicolons. Yep. Okay. Dang, it even tells us what to do. Like, dude, thank you, Rust. Thank you, Rust. Okay, let me save this, and then let me clear this so it's a little neater, and then let me rerun so we have fewer error codes to try to debug. That's much simpler. Okay. So now it cannot find pair in this scope. Line 45. Similarly named tuple struct pair defined here. Okay. Perhaps I messed up and was supposed to spell things uppercase. Let me double check. Let's check the notes, y'all. You can see pate. So this one they didn't catch it totally, but I just spelled something wrong, and that just happens when you're live coding. So cool. Let's rename this pair, and then we should be good to go because pair is a thing that exists here. Okay. Let's clear this again just to make it nice and tidy. And no errors. Nice. Okay. So you can see most of the errors are really simple, trivial, like you're missing a semicolon or it's a typo in how you spelled something. And that just happens, especially when you're learning a new programming language. So it's chill. Just embrace that as part of the learning experience, and you will do wonderfully. And you can see we're printing out multiple points, and nothing is wildly exciting, but we did some destructuring of structs and defined some custom types. So that's pretty cool. Let's move on to the next section of custom types. I'm going to close this file, and then I'm going to create a new file called enums.rs. And now you can see we have two files in this folder. I guess also the binaries. Let's keep going. Before I push the code to GitHub, I'll make sure to delete all the binaries, but we just want to add the Rust files. Cool. So now we have enums. Let's open that up. So the enum keyword allows the creation of any type, or of a type which may be one of a few different variants. And so you can think of like options, like an enum for red, green, blue, if you're thinking about like color on a computer screen, or maybe if you're in like a cafe, enum for, do you want caffeinated or decaffeinated coffee? Shout out to my homies at Boartooth Tattoo in Los Angeles. They're very talented artists. If you're in Los Angeles and you want a tattoo, go hang out there, get some cool art, and plug. All right, cool. But yeah, enums are just ways that it's a struct where you have options that you want to select from. So in the context of maybe the graph, you could think about that as perhaps there's a struct or an enum. I mean, this is probably overkill, but like an enum of indexers that you can select from. or subgraphs. That seems too much. I feel like in this context, you'd want fewer options. But I could see a program being written that way. I don't know how useful it seems kind of not useful. I've seen enums used in the context of like selecting programming languages selecting an algorithm for solving a problem. And so you can create an enum of linear regression or random forest or X algorithm. And then you can just choose between those three. And if it allows you to validate choices nicely. And so if someone picks something that's not one of those three options in the enum, it just gets flagged as, no, this is not valid. Please try again, or whatever logic you implement. Cool. So now let's make an enum. So we're gonna create an enum to classify a web event. And so I guess that could be like a click, pressing of a key, pasting text into like a field, or loading a page. And so let's create a web event enum. So an enum may either be unit-like, so it could like page load or page unload, or it can be a tuple struct like this, key press, or char, paste a string, or it can be a C-like structure. So just trying to further reiterate that there's lots of ways to do things. And I know from when I was first learning just programming in general, this can kind of be overwhelming to see all these different ways. And so I'd encourage you to acknowledge that, like, it's okay to be overwhelmed, but then like realize that don't try to use all the methods all the time. It's okay to just kind of pick one and go with it for a while, and then get comfortable and familiar with that, and then move on and try different things. Like don't feel like you have to use unit-like tuple structs and C-like structs in every program. That's just like, no. They're just really trying to show you the ways that things can be done, but don't feel like you have to do all the ways all the time. I remember when I was first starting out, it could kind of feel overwhelming. Like, is this how it is? Maybe it is in some places, but I don't think you have to use all the ways all the time. But that's just my opinion. Cool. So we have our struct, the web event struct. Actually, let me save that before we go any further. And so now we're going to create a function which takes the web event enum. Sorry, it's not a struct, it's an enum. So the function will take our web event enum as an argument, and it'll return nothing. Which doesn't sound super exciting, but we'll see. Maybe it gets a little more exciting. Sometimes you don't need to return anything. Sometimes you're just doing stuff in the background and nothing actually gets returned. So our function is going to match an event from our web event enum. So you can think about like you have like a bunch of objects or a bunch of stuff to sort through, and then if when you're sorting through it, something matches the condition that you want, you pick it. So it's really just a way to check that things match some condition. So we're using our web event enum, the page load. And so if the event matches a web event page load, we want our program to print, spelling is hard while speaking and typing. It's like that multitasking. We want it to print out page loaded. Don't need a semicolon here, just a comma. Cool. So that's our first match case. Our second one, if it's a web event and it's a page unload, we want our program to print that page unloaded. You can see where we're what we're doing here. It's nothing wild, but it's really just connecting the pieces for the program. Cool. So now, as you can see, we're going to move on to a slightly more sophisticated match syntax, but it's still the same general idea. So if it's a web event and the key press is character C, or I guess just any character, we just want it to print out that you pressed the character. Pressed. And this is nothing mind-boggling. It's really just utilizing the logic that we defined previously, and I'll toggle up after I finish typing this. Okay, let me add that comma. Okay, cool. So if we quickly scan up back here, the key press, it's expecting a char type. And so that's like a C or a B or an H on your keyboard. Next, let's implement the paste case. So if the web event matches paste of a string, we're going to print out that string. The carrots with the right ring finger. I'm weak. I need to start working out my ring finger. Print ln. Pasted. Oh, this one's nasty. Super nasty. Okay. Let me make sure I type that right. Okay, escaping some quotes. Okay. Almost done. For the final web event match, we're gonna do click and just X and Y. And we'll print out one last statement. Clicked at X equals this. Y equals this. I had to change the song real quick. It was kind of weird. I know you guys can't hear it, but got background music on my end. Okay. That looks, oh, and this is where we need the semicolon. Gotta add a comma here. And then, I feel like I'm missing. Am I missing something? No, I'm not. Oh, that's what I'm missing. I don't know why they did that like this. Sorry, I'm talking to myself, but I'm like looking at the docs, just trying to make sure I'm doing things correctly. Okay. Oh, that's weird. Okay. Sweet. So we created our inspect function. Now we can code up our main function to actually run things and make sure stuff's working. So this will be quicker. Just create main. So if let pressed equals web events key press, and if it press X. So now we're going to create an own string from a string slice using the toOwned method. Don't worry about this too much, but it's just kind of ownership within Rust you have to deal with the way that memory is handling information, and sometimes you have to pass ownership of objects. I think this is also a thing in Go, sort of. Languages like Python kind of abstract that away from the user so they don't have to deal with that. But programming languages like Rust do not. Cool. So then let's create a click, web event, click, x20, and then y80. And then we'll do a load. Loaf. I'm hungry, man. I want some loaf. Page load. Let unload equals, you guessed it, page unload. And now let's just do inspect pressed. Inspect. Pasted. So we're just using the function we coded up above and just running it. Inspect. Load. Inspect. Unload. Cool. Now we should be able to run this program, and let's see what happens. So I'm gonna save. And so now let me just edit this. I can be lazy. Enums. And then enums. Something broke. Let's see what broke. It's part of the process, y'all. Yeah, I probably forgot semicolons as usual. It happens. Expected value found enum web event. Interesting. Line 26. Let unload. Missing a colon. Tricky. Those double colons. That's definitely something different from Python. I've only ever seen that in, I guess, like C-esque languages, I guess, like in Rust. I don't know, it's weird. Okay, cool. So we got fewer errors. We're getting there. So now there's something wrong with our web event key press. Interesting. So that's on line 21. Yeah. Okay, what did I mess up here? Let pressed equals web event key press. That's what it is. Rust is very particular about single versus double quotes as it relates to the types of things. And so from what I remember, single quotes are for chars and double quotes are for strings, but I could be wrong. But let's see. I just changed this from double quote to single quote. I expect that to resolve this issue. Let me clear this again. And it's resolved. So sometimes it can be an error as simple as using the wrong type of quote. In Python, it doesn't really matter. So I'm kind of lazy about, or I'm a little careless about switching between single and double quotes. But as you can see in Rust, it's a little more particular about which you choose. So you can see our program just inspected some stuff. It clicked things, or based on what we passed to the inspect function, it printed out different events So we pressed the X character, we pasted the my text string, we clicked a location, we loaded and unloaded a page. So you can see how we're slowly building on the knowledge that we've ingrained in ourselves and just adding on to it. So cool. Let me clear this out. There's also some more in this enum section. In the REST by example docs, they're talking about type aliases. Let me see if I missed anything. Okay, cool, perfect. So you can refer to each enum variant via its alias, and this can be useful if the enum's name is too long or too generic. So you can see previously I was kind of struggling with remembering what was what, and sometimes if you're way too specific, it can be too long to type, and so here's just ways where you're able to reference things using an alias. So let's create a new file. We'll call this type aliases.rs. Let's open it. And so right from the start, let's create a new enum, a super verbose enum of things to do with numbers. Super specific, right? And there's going to be an add and a subtract option. Next, we can create an alias for this enum just to make our life a little easier. And so we can call that operations, and it's going to be the very verbose enum of things, not this, things to do with numbers. Okay. And so typing operations is way faster. And so this is a pretty trivial example, but now we have a main function, and we can refer to the enum via its alias. And so let's instantiate x equals operations add. And there you have it. We can reference the very verbose enum of things to do with numbers via its operations alias. And so I don't believe there's going to be an output on this program, but let's see. Yeah, there's nothing being printed, but as long as we're not getting like an error, that's promising. So we got warning, but that's not bad. It's just letting us know that we have some dead code that we're not using. And so this is another opportunity for us to implement some more Rust functionality. So let's do the warn on unused variables. I believe we did this for the struct class. Yeah, allow dead code. So let's implement that here and see what happens when we rerun it. So allow dead code. Now I'm going to clear this just to clean it up a little bit and then rerun it. Unused variable, warning, unused. Okay, so let's add another one. I don't know if this will work. Okay, let's see what happens now. Hey, no, okay, so if you want to silence the unused variable warnings, you just pass this kind of attribute flag here, similar to the dead code one. So, learning tricks. Awesome. And then there's one final mini lesson within our structs section, and this is about using the self alias. So I guess we can call this self alias.rs. And so let's create another enum. similar to our previous example, very verbose enum of things to do with numbers. And we can add, actually, let's do very verbose enum of things to do with the graph. Make it a little more interesting. So, when we have indexers, we got delegators, we got curators, and I mean, there's more options, but this is like the minimum for this example. And then let's implement a very verbose thing of things to do with the graph. So fn run self. This is gonna be annoying because it's doing like math. Okay, but I can just we don't have to do math. Okay. So we'll say name, and then string. How do you do a string type? Let me double check that. Rust string type. Okay. At static, or just at str. A reference to the string. Okay. Let's see what this does. Self name at static string. I'm just gonna call it str. Okay. And then it returns an str. Match self. If self is of type indexer, we want to say println. We're going off script now, so this might break, but we'll see. Indexer name. Okay. If self, what is this? Delegator. So this is sort of a trivial example, but just trying to integrate a little more graph-centric stuff. But you can see we're really just passing a different prefix of delegator versus indexer name, and then just passing the same name to each one. So on the fly, I'm just trying to create an example that's based off of what I'm seeing in the docs, but a little more graph relevant. Actually, I don't want to do all four, so I'm just going to take I'm lazy. Deal with it. Okay. So we got two options. Now, match self. So let's add a main function now to actually test this. So main. Let's indexer equals so it would be very verbose, and then indexers Okay, I might have to this might break, this might not work, but we'll see. do some Googling. Okay, so the IM. Okay, so then do I just do indexer.run and then Alex? And then I want to add that allow dead code stuff so I don't get a bunch of error. Yeah. I don't want to get yelled at right now. Couldn't read self-aliases.rs. That's because it's not called that. Okay. Errors. Yeah. Indexers. Okay, so it's a unit variant. Chill. So let's try that again. Doesn't like that. Doesn't have a size. Yeah. I'm trying to be tricky and it's not working for me. It happens. All right, I'm gonna scrap this like on the fly option and instead do what the docs suggest. So it's pretty similar, but instead of an indexers, it's add. Instead of graphed numbers, subtract. And then this should be digits. And it returns another integer 32. Match self. If self add. Or if self subtract. So if it's add, we will do x plus, correct, come on, x plus y. And if it's subtract, we'll do x minus y. Okay. And then let's test. Because very verbose enum of things to do with numbers. And then how about we call add. And then we'll do test run. And then let's pass two values. We'll pass a 4 and a 92. So we expect it to return a value of 96. At least I hope. We'll see if it works. Oh, it's not actually printing out. Okay. Print ln. It's like nothing happened. And then we'll just do this whole thing. Hey, 96. Okay, so it works. I was just getting too fancy for myself with the indexers on the fly. And strings are different than addition of integers, so yeah. Whew. We made it through enums. Oh no, we didn't. There's plenty of enums. Okay, there's a ton of enum work. Okay, let's keep going with enums. We're gonna be experts. So let's create another file called use.rs. I'll share where we're currently at in the cool. So the use declaration can be used so that manual scoping isn't needed. So to start out, let's add our trusty allow dead code attribute so that we hide the warnings for our unused code. All right, let's create an enum status. Okay, so I think we're gonna get more into string type stuff now. That should be exciting. Pour. Let's do another enum for work. So whether you work for a civilian company or for a military company as a soldier. And now let's use or create our function. So we only need 2 enums for this little example. Main. So we're going to explicitly use each name so they're available without manual scoping. So you do that by running use create status pour rich. And you can also automatically use all the status or all of the enums inside of, or all the fields inside of an enum by passing the wildcard asterisk, like so. So use create work asterisk, and that'll import civilian and soldier, so you don't have to pass it explicitly. Cool. The next thing. You can also, because we've explicitly using pour and rich, we can just kind of call on pour as such. So status equals pour, and it just Rust knows that we're referring to this pour right here. Similarly, because we imported everything from work, we can do that with civilian, which is defined up here. So now we're gonna do match case, where matching the status. And so note the lack of scoping because of the explicit use above. And so we don't have to worry about like status : rich. We can just say rich. And so it's just a way to reduce the amount of code you have to type further down the line. This is in no way like required, but it's just more of like a helpful trick if you want to use it, but you don't have to. And we're just printing different text depending on the status of the person. So the rich have a lot of money and the poor have a lot less money. They have some money, just not a lot. And then we can create another match status or match case for work. And so we'll do civilian equals civilian's work. And then if it's a soldier, soldiers fight. And so this is civilians. Okay. Now I can save this. And now we can run our code to see what we get out. And we got errors. I expect nothing less. Okay, where did I mess up? So I used semicolons where I shouldn't. Here, for the status match case, you actually have to use commas instead of semicolons. And so this is where syntax is important. Should be fine once I update that. And it's cool. So you can see the poor have a lot less money and civilians work. And the reason we're seeing that is because our program has a status variable of poor and a work variable of civilian. And so based on those variables, our program matched the status and printed out that the rich have a lot less money and that civilians work. Cool. All right. We're on our little, oh, we're getting there. Dang, this is a beefy. So now we got some C-like enums. Touch. C-like enums.rs. Okay. So we're going to use our trusty allow dead code. Let's make an enum called number 0, 1, and 2. And then let's create another enum for colors. Color red equals, I'm going to copy paste this hex code thingy. Green equals this one, and blue equals this bad boy. So we have a couple enums, and now we can create a main function. So fn main, curly braces. So let's print out 0 is, what is 0? Number 0 as integer 32. So I guess we're casting it to integer 32. Make sure I print ln. Next one, print ln. 1 is, guess we're just doing the similar thing. Number 1 as integer 32. Okay, and then we're gonna do the same thing for the colors. Roses are, but we're gonna do a little bit fancier string formatting here. 06x. So I'm assuming this is the notation for hexadecimal formatting, i.e. hex code. Numbers, color numbers. So then color red as I32. So we're going to format our hexadecimal hex code as integer 32. And then I'm going to copy this just because it's so much ring finger typing. Violets are, roses are red and violets are, I mean, they're actually violet, but we could call them blue. Okay, so now we should be able to run this program, get some output using these C-style structs. So let's use our trusty Rust C compiler and pass the C-like enums. C-like enums. A. So 0 is 0. 1 is 1. So it's nice, like our program is just able to automatically convert 0 into an integer 32 representation, which is kind of rad. And then same thing with red and blue. It kind of displays the hex code, removing the OX from the front and just formatting it as a hex. All right. Next, we got test case linked list. Ooh, so I guess this is like a little applied project that we can do. So apparently, enums are used to implement linked lists. So let's call this touch linked list.rs. So we'll use the create list, and we'll, I guess, import everything from there or make everything available. So now let's see, make a list enum. Cons is going to be a tuple struct that wraps an element and a pointer to the next node. And then nil is a node that signifies the end of a linked list. So now we're going to attach some methods to the enum. The list enum, to be specific. So we're attaching a new method. We'll create a new list. And it has a nil type list. Cool. And then besides the new method, we can add a prepend method. Self, so referencing the list self object, lm of type unsigned 32, and so it consumes a list and it returns the same list with a new element at its front. So prepending a list. And so now cons has a type list. Self. Okay. And so now we'll create another method to return the length of the list. Length of self. It'll return an unsigned integer 32. So match self. Cons. Okay. We're gonna add one more method before we start our main function. So we'll call this stringify. Reference to self. And then it returns a string. And you can see it returns a representation of the list as a heap allocated string. Match self cons head reference to the tail. And then format. We're just printing out some information. Head tail dot stringify. Then nil. If nil, we'll format nil. So this is really just matching self. If self is cons, then return this representation, and if it's nil, return nil. Okay, nice. Now we can code up our main function and test out our linked list. So we're going to create a mutable list using our new method that we coded above. Then we're going to prepend some elements to our list. And then finally, we're going to print out the final state of the list. Okay, let's save it. Let's run it. Let's see if we got any typos. Typos. Okay. Expected one of the following. On line 21. Okay. Match self. Cons. Rectangle 1 plus 2 dot len. Okay. Oh, that's what I'm missing. Okay. Let's clear it. Run it again. Okay, close. One typo. I'm missing an L on line 43. Right there. Okay. Create a list of length 3, 1, 2, 3, and then it printed out the items. You could see we could do list equals list.prepend. Let's add a 7. See what happens. Length 4, 7, 3, 2, 1, nil. Cool. It's a linked list. All right. And then for our final, I guess, exercise for today's custom types, we're going to pivot to constants and do a little bit more coding. So let me create one last file for today. I believe that, yeah, just one more. And then we'll call it, so touch constants.rs. Okay, so global, okay. Rust has two different types of constants, which can be declared in any scope, including global, but they both require explicit type annotation. And so the two methods are the const method and the static method. And so const is an unchangeable value. That's the most common case. And then static is a possibly mutable variable with a static lifetime. And so the static lifetime is inferred and does not have to be specified. Accessing or modifying a mutable static variable is unsafe. So let's create a static variable called language of type string, and we'll pass a value, or the string rust. Let's create a constant called threshold of type integer 32, and we'll give it a value of 10. Next, let's write a function called isBig to see if our number is big. And so it takes n of type integer 32 as input, and it returns a Boolean output to let you know if n is big or not. So if n is above a threshold, it's big. Otherwise, it is not big. And so if n is greater than threshold, it'll be true, otherwise false. So let's create a main function. We'll let n equals 16. So we expect it is big. Next, let's print out our language. This is language. And we can print out our threshold. If the threshold is threshold. Next, we can do print ln blank is blank. The first blank is n, and the second one is if is big n, return if is big n is true, return big, else return small. Cool. That definitely needs a semicolon. And so let's save this and run it. Constants. And then this is Rust. The threshold is 10. 16 is big. Cool. If we change this to a different number, say 4, I expect it to be small. 4 is small. Cool. And then one last thing, you can also, if you try to edit a const or modify a const, you'll get an error. And so just to show you that, let's try to change the value of threshold to be 5. Threshold is a global const. And so we're trying to modify that in the function, but it's not mutable, so I expect us to get an error. Let's see what happens. We got an error. So yeah, you cannot assign to this expression. Okay. We comment it out. We're good to go. All right. Well, I feel like this is a good stopping point for today. We finished the custom types subsection. We went deep into enums, and we covered a bit about structures and constants. Our next session will be going into the variable bindings as we proceed further down Rust by example. We're getting there. It seems like there's 24 sections, and today we finished 3. So we're making progress. I mean, it takes time. There's a lot to learn, but I'm pleasantly surprised with our progress and looking forward to learning with you all over the coming months. But yeah, I'm going to stop recording now and take a little break, a few minutes, and I'll be back in half an hour for our Kubernetes code along. But yeah, I'm going to stop recording, but I'll be here for a few minutes. I'm starting to stutter. I need to take a break.